Staring at my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be taking a look at Python's special methods. So what are these special methods? Well, they're also known as magic methods or dunder methods, which stands for double underscore. And these are predefined methods that have names surrounded by double underscores. And we've already seen a few of these, like underscore underscore init, underscore underscore, and that would be the constructor for our objects. But they can do many more things. These methods allow objects to be defined in a way that changes their behavior, such as when we use them with certain operations. And this really helps make Python's classes more intuitive and Pythonic by mimicking the native Python functionality. So what kind of special methods do we have available? Well, the first set of special methods affects the life cycle of objects. And we've already seen one of these, the init method, which helps us create our object when it's first initialized. However, there's also another method called delete, or DEL, and this is called when an object is about to be destroyed. So to summarize, the init method takes a series of parameters, and that allows us to initialize our object by doing things like setting up instance attributes. And this is called just after the object is created. It has some key features such as it sets up instance attributes, and it can accept additional parameters for initialization. Usually these are the values that we're going to be storing in our instance attributes. The other method, which I just mentioned, delete, doesn't take any parameters other than simply the self parameter, and it's used to clean up resources before an object is deleted, and that's called just before the object is destroyed. In our object references video, we talked a little bit about the life cycle of objects, and remember, when all references to an object are gone, it means that that object is eventually destroyed by Python's garbage collector. Just before that happens, this method is called, and it's great because it allows us to clean up for certain tasks, maybe close files, and do anything we need to. But it's also important to note that this method may not always be called. If something dramatic happens, like the program is suddenly terminated, it's not going to run. So let's now take a look at an example using both of these methods. And this example is going to be for a file handler class that's going to help us deal with writing to a file. So the first method we have here is our init method. This takes a file name, it sets up some instance attributes, in this case both file name and file, and one of the big things it does is it's going to open the file for us. So we could add some extra error checking here, but basically what it does is it takes that file name, it stores an instance attribute, and it also opens up the file in write mode. And then to the terminal, it's going to output file, the file name, opened for writing. And this is useful because as soon as a new instance of this class is created, it's going to open up the file for writing. We also added the delete method. And remember, this is going to be called just before the object is destroyed, and it's going to close the file and write to the terminal, file, whatever the file name is, has been closed. We also have a write method in there, and the write method is simply going to write to the file using the file's write method. And it's going to output to the console, written to whatever the file name is, and then the text it written to it. Now, an important thing to note here is this is just sort of a silly example. In real life, we'd want to add a lot more error checking to something like this, and we might run into issues like if two of these were created and tried to write to the same file, so we need to check for things like that. But for now, it is a good demonstration of these methods. So what are we actually doing with this class? Well, one of the first things we're doing is we're making an instance of the class. You can see that we're calling file handler, and we're passing it the file name example.txt. As this object is created, it's going to call the init method. This is going to open the file up and print out to the console. We get something that looks like this. File example.txt, open for writing. Then we're going to write to the file, and we're going to do that by manually calling the write method. This is going to output to the console, written to example.txt, and then what we wrote to the file, hello world. The last line is a bit more interesting. We're using that delete keyword that we saw in the last video to delete the reference to the handler object. Because there's only one reference to this object in handler, When we delete this, there's no longer any references to the object, which means Python's garbage collector is going to destroy the object. Just before that object is destroyed, the delete method is going to be called. And what we do in the delete method is we close the file. It's always a good idea to close files when you're done writing to them. And then we output to the console, file example.txt has been closed. Now, it's important to mention that this method can be called in other ways, not just when we manually delete a reference using the delete keyword. This is called whenever the object is destroyed, not whenever the delete keyword is used. So if we had multiple references to this instance, then it wouldn't be called until the last reference was deleted. And that last reference could be deleted for reasons other than manually deleting it with the delete keyword. For example, the variable could fall out of scope, and it would eventually delete that reference. If that was the last reference, then it would be collected by the garbage collector. So just keep in mind, if you rely on this delete method being called, that this may happen when the program ends if there's still a reference, but it's not guaranteed. It's going to depend on the order those references are cleaned up. So we just saw two key special methods that are used in the object's lifecycle in Python. But Python provides special methods for far more things. For example, we also have special methods that define how objects should be converted to built-in types like string, int, and float. We've already used these indirectly. For example, when we've been working with objects that are already built in, like strings and lists and tuples, we sometimes send those right to the print function. The way those are converted to a string before being output to the console is that these special methods are being called on those objects. In the case of things like strings, tuples, and lists, Python already has a class predefined that defines how these work. They define these special methods. But we can also add these to our own classes. So we can use them in string function, in the print function, the int function, and the float function. Let's take a look at what these look like. So these are the four most common ones. And the first one is the string special method. And this works with the string function that's already built into Python. And its purpose is to define a string representation for the object. And this should be a string representation that's useful for like an end user, not necessarily the programmer, that's descriptive and human readable. And this is triggered when we send it to a function like print or string, and it converts the object into a string. The next one is the repr function, R-E-P-R, and what this does is it also converts the object into a string. Except this representation is made more for debugging purposes and developers. The representation is supposed to give you all that you need to know to recreate this object. Usually that's done by actually outputting a line that resembles Python code that you could use to recreate the object. Next is the int method, and this converts the object to an integer if that makes sense and it's possible. It's used with the int function, and when you call the int function on your object, it's going to call this special method, and that's going to determine how it's converted. Float is the same idea. It's going to be called when we try to convert the object into a float using the float function, for example. Let's take a look at an example. Here we have a class called temperature. And what this simply does is it stores the temperature in degrees Celsius. And it stores this in an instance attribute called Celsius. But what happens if we were to try to print an instance of this class? For example, what happens if we make an instance of the class for the value 36.6? Presumably this is degrees Celsius. And we store a reference to this instance in the variable temp. And then on the next line, we try to print it out with the print function. Well, if we did this and ran the program, we would get an output that would look something like this, which states this is a temperature object, and it's currently located at this address in the computer's memory. Now, this representation could be useful if we're doing some debugging, but for most of the cases, we're not going to want this. We're going to want output that actually says what temperature is stored in the object. And that'd be far more useful, for example, to end users of our program. So there is a way to change how this works with print and the other conversion functions. So now we've added a few special methods, and we'll go through and explain them. First, we have the string method, and this is called when we convert the object to a string using the string function or the print function. In this case, we're simply going to output a string that has the degrees Celsius from our Celsius instance attribute, and we're going to add on the degree symbol and a C to denote that this is in Celsius. Next is the REPR special method. And again, what this does is it creates a representation of the object that we could use to recreate that object. This is mostly used for debugging purposes, as well as communicating things to developers rather than the end user. Typically, we want this to output something that we could use by either pasting it back into Python or the Python console to create a new instance of this class that would have the same values. So in this case, we're outputting the name of the class, temperature, and the values that we would send to it when we're creating an instance, which in this case is just the Celsius value. So this will return a string that says temperature, a parentheses, in this case the value 36.6, and then another parentheses. Next is the int special method, and this converts the object to an integer if that's possible. Same thing with float, it converts the object into a floating point value if that's possible. So let's see how this is used. Here we have a new list of print lines, and each one of these tries to print the object in a different way using some of the built-in functions we've already seen that try to convert objects. And this is the output we'd get in this case. So the first line is caused by this first print statement, and this is sending our object to the string function. The string function tries to convert the object into a string, and it does this by calling the string special method. So we get 36.6, the degree symbol, and C in this case, which is just what our special method says to do. Next, we are just sending the object directly to print. And the way this works is print is going to convert the object into a string first before it outputs to the console, and it does that by calling the string special method. So again, we get the same value here. Now, this is a little bit new. I don't think we've seen the REPR built-in function before, but what this does is it simply calls the REPR special method and creates a representation of the object that's more useful for developers that we could use to recreate the instance of the class. So here we see temperature, parentheses 36.6, parentheses, and that's something we could paste back into our code to make a new instance of this object. Now we're sending it to the int function, which converts it to an integer. So that calls our code here, which uses the int function to convert Celsius into an integer. This simply just chops off any decimal places. It's important to note here that call to the int function inside the int special method isn't calling itself, it's not a recursive call. It's calling this int special method on the integer object, that is Celsius. It's not calling the int on the temperature object. Lastly, we're doing the exact same thing, but with float. So we're trying to convert the class into a floating point value, so this calls the float special method. Here we use the built-in float function to try to convert that Celsius instance attribute into a float. In many cases, it probably already would be a float, and that works fine. But in case the user put in something silly like a string, this would also work, assuming that string is formatted in a way that could be converted into a floating point value. Now, there is one special case I should note, and that's what happens if we don't have this string method here. Now, you might think that without the string method, it's just going to fall back on the behavior that we saw before and output that memory address of the string. But that's actually not the case. If we were to delete this string method and run the program again, we would get this output where it says temperature, temperature, temperature. So what's happening here is if we don't have the string special method defined, but we do have the REPR special method defined, it will fall back on using the REPR special method. So in this example, when we sent the object to the string function, as well as when we sent the object to the print function, because the string special method wasn't defined, it uses the REPR method instead. So that's something that's important to keep in mind when you're writing these special methods for your programs. That REPR is only going to be used by string or print if the string method isn't already defined. So we've now covered two different ways to convert our object to a string. One is with the REPR special method, and the other is with the string special method. But when do we use each? Well, here I have a few best practices and recommendations. So the REPR special method should be used for technical people. This is used for developing and debugging, and it should create a technical representation with all the information we need that's unambiguous, and we can use to recreate the object. Whereas the string special method, or str, should be outputting a user-friendly, human-readable output that explains what the object is and what it contains to the user. This should be something that we could provide to the end users of our program and would also make sense to them. So really, these two special methods complement each other. String is used for end users, while Reaper is used for developers and debugging. Now, the other type methods like int and float should be used only when there's a logical meaning to converting the object to an integer or a float. I shouldn't feel like we should include these for every single class. We should only include them if it makes sense that we can convert this object to an integer or we can convert this object to a float. If these don't make sense, then we shouldn't define them because we don't want to make it possible to do something like return just a 0 if that 0 has absolutely nothing to do with what our class is about. So we always want to ensure these conventions are accurate and meaningful. If they're not, don't include them. Now, there are far more special methods in Python, and we can take a look now at some that are used for comparing different instances of an object. These methods allow classes to define behavior for operations like equals, not equals, less than, less than equals, greater than equals, and more. So I have some of the most common ones in this table here. And you can see for each one of those comparison operators we have, like equals, not equals, and so on, there's a different special method to define how that's going to work for instances of our class. Now, the important thing here is the order of the parameters or the arguments that are sent to these functions. So self is always going to be the first object used in the operation. So in this case, where we have object 1 equals object 2, which is the equals operation or equality operation, object 1 is going to be the value of self. That means we're calling this equals special method on object 1. And the argument, or the parameter in this case, is going to be object 2. And this is true for all of these different special methods. The leftmost one is going to be sent as self. That's the one that we're calling the special method on. And the rightmost is going to be the one that is the argument to the method. So let's take a look at an example of how this works. Here we have a very simple class called car, and it simply takes in 3 arguments, make, model, and year, and stores them in its instance attributes. Now let's say we make 3 different instances of this car class. We have a Toyota from 2020, we have another Toyota with the same values, exactly same year, same model, same make, and then we have a third car with some different values. It's a Honda, it was made in 2021, and the model is Civic. So what happens if we try to compare these without defining any special methods? Well, we're going to get false output twice. So even though car 1 and car 2 have identical values, they're not the same object in the computer's memory. So remember from our previous video on object references, when we use the equals operator like this without any special methods defined, it acts just like the is operator. And the is operator checks if both of these objects are the same objects in the computer's memory. And just because they store the same values doesn't mean that they are the same object. So car 1 and car 2 are being output as not being equal because they represent 2 different objects in the computer's memory that just happen to have the same values. But maybe we don't want equals to work like this on our class. Maybe we want it to output true if all of the values are the same. So if cars have the same make, the same model, and the same year, it should output true. How could we fix this? Well, we could define some of those special methods. Here we're adding 2 special methods, the equals special method, or EQ, and the not equals special method, NE. Now, what the equals special method is doing is it's first checking, is this an instance of a car? Remember, just because we can compare 2 objects doesn't mean they're objects of the same class. So we could get into an issue if we try to compare, for example, a car to a dog, or a car to a person, or a car to anything else that doesn't make sense. So the first check we're doing in equals is seeing, is this other object actually a car? If it's not a car, we're going to return false. We're going to say a car can only be equal to another car. Next, we're checking if all of the instance attributes have the same value. So this is checking if the value of make and the current object is equal to the value of make and the object it's being compared to. It's also checking model and year. This has all just been shoved together on one sort of long line. And this is going to return a Boolean value, either true or false. It will return true if all of these are the same, all equal. And it's going to return false if any of them are different at all. So that means we're redefining the equality operator to return true if they're both instances of a car and they have the same values in their instance attributes. Next, we have the not equals special method. And we've simply defined this as being the opposite of what the equals operator returns. So we're saying self equals other. This means that it's going to call that equals special method on the current instance of the class. And then we're using not to flip that. So if the equals special method returns that they're true, it's going to flip that to false. If it returns false, it's going to flip it to true. So it's basically just saying output the opposite of what equals would. So let's test this out with a few print lines. The first print line here is going to output false. The reason why is we're using the is operator to check if car1 and car2 are the same object in the computer's memory. They happen to have the same values, but they're not the same object. So this is going to return false. The is operator doesn't follow the equals special method. It just makes that check. Are they the same place in the computer's memory? So defining these had no effect on is. But what it did have effect on is the equals operation. So this is checking if car1 is equal to car2. Before it was returning false because it defaults to the same thing that is does. Check if they're the same objects in the computer's memory. But in this case, we define the equals special method, which overrides that behavior. So now it's going to follow our method, which checks to see if the make, model, and year are the same, and they're both car objects. In this case, they are, so it's going to return true. Next, we're doing the same thing with car1 and car3. But car3 has different values for its make, model, and year, so our equals special method is going to return false in this case. Next, we're calling the not equals operation. We're saying, is car1 not equal to car3? And this is going to trigger our not equals special method, the NE method there, and this returns the opposite of what equals says. So car1 and car3 are not equals because they have different values. So not equals is going to flip that and we get true. So the important thing here is by default, equals is going to compare these objects in the computer's memory and see if they're the same object, but we can override that behavior with these special methods to change how they work, which can be extremely useful. These special methods aren't just for comparison operations. Pretty much every operator in Python has a corresponding special method that we can define for our user-defined classes. And this allows us to customize the behavior when these operations are used on instances of our classes. Here's a list of some of the most common ones. And you can see these are all the operators we've talked about earlier in this course. They're things like addition, subtraction, multiplication, division, floor division, modulo, and so on. And each one has its own special method. For example, for addition, we have add. For subtraction, we have sub. For multiplication, we have mul, and so on. And these work just like the special methods we saw before, except instead of returning true or false, they return some value that is the result of this operation. And again, they occur in the same order, the arguments. So here we have self, which is going to be the first object, the one on the left, and other is going to be the object on the right. That means we're calling the special method on the object on the left, and we're passing an argument which is equal to the object on the right to the special method. Let's take a look at how this works. Okay, here we have yet another class, and again, it's fairly simple. This is a vector class that's going to store two values, an x-coordinate and a y-coordinate. But what happens if we tried to add two of these vectors together? So we're creating two instances of the vector class. Vector 1 has the coordinates 2, 3, and vector 2 has the coordinates 4, 1. And we're trying to add these together using the addition operator and print out the result. The issue is this would cause a traceback error by default, because no one's defined how addition works on the vector class. So without that being defined, we would get a type error saying that this operation is unsupported on vector. But we can fix that. Here I've updated the class and I've added a bunch of special methods. So now we have special methods defined for addition, subtraction, and multiplication. The addition special method does two things. It first checks if this is another instance of vector, because we want to define this so we can only add two vectors together. We don't want to be able to add like a vector in a car, a vector in a person, a vector in a dog, because that wouldn't really make sense. So the first thing we do is we'll check to make sure that this is a vector. If it's not, we're going to return a type error. If it is a vector, then simply what we do is create a new instance of the vector class, and it's going to be equal to adding the x coordinates together and the y coordinates together. Now, the add method can return other values. We could return an integer result, for example, but I think what would make most sense in this case is creating a new vector that has both of the values combined. Similarly, we have the subtraction special method. Again, we check, is this an instance of vector? They must both be vectors for this to make sense. And if they are, then we simply subtract the one vector from the other and create a new vector with the result. Now, the multiplication down here is a little bit different because it's scalar multiplication. So instead of timesing a vector by another vector, we're going to be timesing it by either an integer and a float. So in this case, the other value is going to be either an integer and a float. If it's not, we're going to raise a type error. If it is, then we're going to multiply each coordinate by that scalar value. And there's a few interesting things here to note. We can see that we don't always have to use two values of the same class. For example, here we're multiplying a vector by a scalar value, either an integer and a float. So we can, and we are free to define our different special methods to allow things like multiplication, subtraction, and addition between something like an instance of our class and some other type. And we've already seen this with some of the built-in types. For example, if you multiply by a string by an integer value, it does string repetition, and that's how this works. Similarly, if we multiply a list by an integer value, it replicates that list by making multiple instances of the elements. So in this case, if we times our vector class by an integer value, it's going to multiply each coordinate by that value and return a new vector. Okay, let's try these different special methods out. And you can see we've updated the code that's using this class to call a few different operations on instances of vector. And the first output we can see here is 6, 4. And this is being caused by adding vector 1 and vector 2. So in this case, vector 1 is on the left. So that means we're calling this special method on vector 1. And it's being passed the argument of vector 2. They're both vectors, so it passes our check. So what it happens is it returns a new instance of vector with both values of x added together and both values of y added together. This doesn't impact the original vector objects, vector 1 and vector 2. It just creates a new vector object, vector 3, with the sum of both of the coordinates stored in its coordinates. So in this case, it would be 6 and 4. The next output is the result of subtracting vectors 1 and 2. Again, vector 1's on the left, so this is calling that sub special method on vector 1, and it's passing it vector 2 as other. They're both vectors, so they pass the check, and it results in a new vector, which would be vector 4, and that's going to be the result of subtracting the x values and the y values. And we can see here we get -2 and 2. Lastly, we do scalar multiplication. So here we're timesing vector 1 by an integer value that counts as an int. So we return a new vector that's a result of each coordinate being times by that scalar value, 3 in this case. And that results in 6 and 9 being output. Now there is one other new thing in this example that I don't think we've seen before. We've seen the isInstance function in a previous video, and we know that this checks if an object is an instance of a class. But I don't think what we've seen so far is passing a tuple as the second parameter. In the examples we've seen before this, we just pass it one class name. And that will check, is this an object of that class? But isInstance also supports a tuple, and it can be a tuple of any number of class names. So in this case, we're giving it int and float, and this means that it's checking if the scalar value is an integer or a float. If it's an instance of either, it's going to return true. So that can be quite useful then rather than having a bunch of different if lines for checking each single possibility. Instead, we can just send it one tuple of the list of different classes to check it against. Okay, so what are the key takeaways here? Well, Python has a ton of these special methods. They're also called magic methods or dunder methods. And these allow customization of object behaviors for operations, built-in functions, and other Python constructs, as well as controlling the object's lifecycle. So these special methods are great because they increase usability, readability, and functionality of your classes and objects. It also makes it far easier for other people to use your classes if you're sharing them with them. Being able to just send an instance of a class to print is a great way to do debugging, and it makes things a lot easier for everyone. And you should note that these are not the only special methods that exist. Python has tons of these, at least one for every possible operation. If you'd like to see a full list, you can see that in the documentation for Python's data model. And I have a link to that here. It might be fun to explore because there might be some special methods for things you haven't expected. For example, we have special methods for collections. So we could also create our own collections if we wanted to make our own version of a list, and there's special methods for that. There's also special methods for how getters and setters work. So please take a look at that if you're interested, but for now you should at least focus on the ones listed in this video, try them out yourselves, and try making some classes that define these special methods. That's all I have for you in this video. Thank you for watching, and have a great day.